Okay, I think that we can start at this point. So, thank you all for being here. It's always nice to see a lot of people taking part to our webinars. Let me introduce myself. My name is Matteo. I am a product manager in Move Solutions, and today we are going to talk about railway monitoring. We're taking the chance to show our new railway tool, which is being released soon. And and basically I will walk you through the understanding of what can be done in terms of railway monitoring and how we interpret the railway monitoring and how we show the data with the new tool. So this is the idea. Okay, let me see. I have a question. I just want to read it real quick. I know this talks about railways. Okay. Okay, so let's keep going. So first off, since that we probably have attendees that have not, participated to previous webinars. Let me just introduce the company a little bit. Move Solutions is a company that designs and manufactures structural health monitoring sensors. We was born at this point, I think 5-6 years ago, and our founder and current CEO was working with an engineering firm at the time. He was developing a system that he ended up it was patented later. And this system is a dynamic displacement sensor that that we patented later. And you can look at the previous webinar on our website just to understand the whole dynamic monitoring, and that's because that's part of that. But just to tell you that that's how we started our journey. And then shortly after that, unfortunately, we have the Morandi bridge collapse in Italy, and a lot of people lost their lives. And after that, as you can understand, as you can imagine, the interest towards structural health monitoring with infrastructure owners and organization grew a lot. And that gave us the possibility to grow in Italy. And then, we expanded to Europe in the following year. And then we were able in the last couple of years to reach United States, Canada. So now we're located also Australia and South Africa. So we're located pretty much all around the world. So going back to today's topic, the railway monitoring, let me just talk very quickly about the system operation first, because this is something interesting in order to understand then what I'm going to talk about later in the presentation. So let's see. There it is. So system operation, how does the sensor work? On the left-hand side of the picture, as you can see, there's the sensors. So the system has the sensors. The sensors are wireless. And the sensor detect all the information and send the data through the gateway to the servers. Now, the gateway communicates with the sensor with a LoRa protocol, which is a long-range low power protocol that gives us the possibility to reach very, very long distances with a low power consumption on the sensors. And then the gateway has an Ethernet connection that gives the gateway the possibility to send the data to the servers with an LTE connection that can come from a SIM card, or if you have an Ethernet line, that can be used as well. And then the data, once it's on the server, it's stored, it's processed, and then it can be shown. Let's say that the default option for that is the Move Solution platform. So the Move Cloud platform, and the tool that I'm going to be talking about today is the Move Solution platform railway tool. So we have a platform that gives you the possibility to see the data processed with certain algorithms and shown in a way that it's easy to understand. But there's other options as well. We expose the API so you can retrieve the data from our servers with the APIs and show the data in a different platforms if it's necessary. So the system is extremely versatile. But this is, the system operation, just an overlook, just to understand. Well, let's dive into the actual railway monitoring. So, of course, when you're doing a railway monitoring, the idea of having battery power sensor can make your life a lot easier. That's because, of course, especially in a railway application where the sensors are installed basically in a line, it's extremely easy to reach very, very long distances between the first and the last sensor of your installation, because again, you're installing basically the sensors in line. And so, having sensors that are easy to install, so they do not require any wiring, and at the same time, they're battery powered, again, and and they give you, the possibility to, to reach long distances without the need of any wiring. Well, that's definitely something. Oh, I just have to stop for a second. I have a question. Do you guys see my presentation? Because I think there might be, I'm just waiting on somebody to comment. Oh, okay, that's perfect. Okay, thank you. So, sorry about that. So, as I was saying, so having a system that is extremely easy to install and at the same, so it's battery powered, and at the same time, we can go up to 8 years of battery life. So it's extremely low cost in terms of maintenance, can make your life extremely easy if you're performing a railway monitoring. So let's go into, the first thing I want to show you is where does the information come from when it comes to the railway monitor? Well, the sensor that we're talking about, it's basically the tilt meter. So our tilt meter, and by the way, there has been, some sort of an upgrade on a couple of features on the tilt meter that I want to talk to you about today. So, the tilt meter can basically detect the angles. So the tilt meter works on a cadence. So you can set a cadence on the tilt meter remotely from the platform, and the tilt meter would just provide the value of those angles that it can detect with a certain frequency, with a certain cadence in time. So let's say once every 2 minutes, once every 5 minutes, whatever it is, you can just have this, this option of having a fixed cadence, and the data just flows with that specific cadence. Well, it is an extremely precise and accurate sensor. And there is a couple of features that I want to talk to you about when it comes to the upgrade that I was talking about, because now we also have the synchronization, which is something I think extremely interesting, which means that all of your tilt meters on your structure would provide their sampling with 1 second of synchronization between each other. And at the same time, the communication between the sensor and the gateway is optimized by using a 16 channels module. So this is something, again, extremely interesting to talk about, when it comes to the tilt meter itself. So of course, the tilt meter can always provide a parameter of temperature, which is actually our entire system. Every single sensor would sample the temperature alongside the actual measure that we are measuring with that sensor, and we always show the platform. But let me just go straight to the tool. So, okay, so when it comes to railway monitoring, what are we doing? First off, what's the purpose of the railway monitoring? The idea is just try to understand and try to detect certain parameters that can make you understand how the tracks are moving and how the tracks are changing in terms of geometry. Those parameters are basically 3, the main parameters that we can detect. The first one is the cant. The second one is the twist, and then there is what we call the vertical settlement. So now I'm just going to go, and then of course we also show the temperatures alongside that information, again, because as I was saying, every single sensor has a temperature sensor integrated that provides along with the sampling, the temperatures as well. So let's go straight to the parameters. So the Cant, what is the Cant? The Cant is it's basically, the definition would be, it's the transversal slope of the tracks. And it's basically the difference in height between the two rails. So if you take a railway tie, on a railway tie, that railway tie can rotate. And the rotation of that railway tie, which can be collected with a tilt meter installed on the tie itself. You can see that, the arrow is pointing at that tilt meter that is installed on that railway tie. Well, that tilt meter is detecting an angle, which is the angle of rotation of that railway tie. Then we have the algorithms on the platform that can process that data and can give you basically the difference in height between the two rails that tie is connecting. So if you take a cross section of the railway at the level of that tie, you will see that, as you can see on the left hand of the picture, which is the actual cross section. So you will see that there is a rotation. That rotation can be expressed in millimeters as basically the difference in height between the two rails. So this is an extremely interesting parameter that basically tells you if if the railway is still, let's say, flat, or if it's actually moving in that sense. A second parameter that comes straight from this one is the twist. The thing is that I can calculate the Cant, so the difference in height between the two rails, I can calculate that parameters at different sections. So the thing is that if there is a change in the Cant between one section, so between one tie and the next one, so if there is a change in that parameters, it means that there is a twist in between those two monitored section, on your railway tracks. So the twist is just that parameter that stands for the rotation, the twist, the torsion of your tracks. And this is probably the most interesting parameter to monitor because the derailment is typically associated and can be definitely associated with the twist. So, when the twist become concerning, well, that can be, one of the leading cause of derailment in the railway industry. So now let's go to Move Solutions approach on those, on the monitoring and of those two parameters, and the Move Solutions approach and how we show those two parameters. So we basically, for the both of them, the approach is the same. We show two different graphs. And here's the reason. The first one is what we call the Cant in the space domain, or the Cant along the tracks. So the idea is just basically to look at the railway, fix the time, and for that specific time, we can provide basically on a graph, we can show you the evolution of, in this case, of the Cant along the tracks. So the purpose of this monitoring is just to locate in one single picture, in one single graph, you have the possibility to locate the areas that are, let's say, Cant critical, and focus your attention on those sensors that are providing values of the Cant that you consider critical. For example, in the picture that you see here on this slide, you can see that, there's like around the center of that graph, there is, the Cant has higher values, and then it goes down to basically 0. Well, maybe for you, those high values are concerning. And so what you can do at that point, since that every single one of those columns stands for one sensor that is providing one value of the Cant along the tracks, you can just go on the graph below and see the Cant over time at that point. So at that point, you can focus your analysis on that specific monitoring point, on that specific tilt meter that is providing that value of Cant that is concerning, and you can see how that value changed in the past, I don't know, a few days, few weeks, in the past year. So you can see basically the evolution of that parameter that led to that value that now is concerning. So you can see, how it changed. If it was if it was a fast trend, if it was a slow one, So the first level of the analysis is the Cant in the space domain along the tracks, just to locate the areas that are concerning in that sense. And then you can go and look at the single sensors and the evolution of that parameter over time. Something else that we of course do is the temperature. So every single measure again is associated with the temperature. So we also provide for that specific sensor that you're looking at when you're looking at the Cant in the time domain. So you're looking at one specific sensor. We also provide the evolution of the temperature for that sensor. When it comes to the twist, it's basically the same thing. So the twist, the approach is the same. So we provide a graph where we show the twist and the distribution of twist in the space domain, so along the tracks, just to locate the areas where the twist is higher, and so maybe the areas where it's worth expanding the analysis and looking at that point at the twist in the time domain. Okay, for that specific sensor. Well, in this case, it's actually for the couple of sensors, because I was saying the twist is always the rotation. It's a parameter of torsion of the tracks, and it's used using two sensors. So it's the Cant in one section, so the Cant provided by one sensor, and the Cant provided by the next one. Well, the difference between the two of them, it's a parameter then is processed, and that is basically what becomes the twist. So it's the difference between two Cants. So you can look at that in the space domain again and in the time domain to see how it changed in the past few days, weeks, years, whatever. About the temperature, of course, since that for the twist we're talking about two separate sensors, we provide a graph with the evolution of the temperature for those two sensors instead of just one. But it's just the evolution of those two sensors that you're looking at when you're looking at one twist trend in the time domain. So now we were talking about Cant and twist, so the deformation of the tracks. Now there is another parameter that is actually important, and it's what we call the vertical displacement or vertical settlement. So it's basically, let's say the tracks. Of course, the tracks, since that the load that is passing over the tracks on a daily basis is extremely heavy. So with time, it might definitely happen that the tracks may be sinking, for many reasons. Maybe there is an excess of water in the soil underneath, or maybe the ballast is losing strength. Whatever is the reason, it's very typical to see the tracks sinking, and that is one of those parameters that is interesting monitoring. So we do that with a little bit of a different approach. The sensor is still the tilt meter, but in this case, we actually use what we call the tilt beams. So basically, a tilt beam is a metal beam, and it's basically a metal beam with a tilt meter mounted on top of it. So the idea is just to connect. So the tilt beam can have different length, 1 meter, 2 meters, 3 meters, can be customizable. And the idea is just to connect many beams together, many tilt beams together in a chain. You can connect the chain directly to the railway tie or to, on the ground next to it. And basically what it provides, every single tilt meter, so every single tilt beam provides basically the angle of rotation of that beam that the tilt meter is connected to. But the interesting part is that with our algorithms, you have the possibility, since that you have all of those beams connected together, and every single one of them, it's synchronized in providing those values of rotation of that segment. So we can basically rebuild the broken line on the platform that basically approximates that deformation of the ground. And this is what you see in this graph. It's basically from point A to point B, which is the limits of the section that you're monitoring. We can provide, again, that profile of deformation, and you can read directly on the graph the value of that deformation. Well, in this case, it's actually a deformation on this picture specifically, which is positive, so that the ground is going up. But in a general sense, you can just see the movement on the vertical plane of that monitoring point. So you can see how it's moving vertically, which is extremely interesting, again, for for the reason that we've been talking about. So, alongside all of that, so now I've been talking about how we show the data, how we process the data. On the, let's say on the back end, there is also a configuration section. So it's really the tools is extremely interesting. I'll show you that on the platform in a minute. So the tool is extremely interesting because it gives you the possibility also to configure your own system. So you have the possibility to divide your project into different sections, what we call sections. So I don't know, for example, there is maybe there is a tunnel section, and then you're monitoring maybe the section that is just before a cross level, and then you want to, of course, you cannot install the sensor, in the middle of the road if there's a cross level, so you have to go past it, and so maybe it's a different section. So the section is just the idea of having, the sensors in a group and seeing the data all together for that specific group. So just grouping the informations together and seeing on a graph. So this is what is behind the concept of sections. So you can create your own sections. You can drag the sensors in. You can create, multiple sections and see them on the tool separately. But I'll show you that in a minute because I'm going to open up the platform. I'm going to show you our demo. So again, there is the configuration. You have the possibility, of course, to add some information to the section. You have the possibility to say, okay, this section is going from, I don't know, New York City to Philadelphia, or the other direction. So you can also say in which direction that tracks are going towards. And, well, I mean, in terms of the explanation of the tool, I think I'm done at this point. It's really interesting to take a look at the platform. So let me just share my other screen, and here we are. Okay, so you should be able to see our platforms now. So as you can see, there's a management section where you can see all of yours. We have already created, this is a demo platform. So we have created some, demo sections where you can see the data. This is, again, all the sections that have been created. In here, there is, of course, the sensors that belong to that section and that provide the data that you can see together on the graphs. You can easily, if you go on the section page, you can, for example, add a new section. So I just try it out. So there would be section 1. So you have the possibility to set, for example, from New York to, I don't know, Pittsburgh. You can add a description. For example, typically you could say from southwest to northeast, for example, just to understand, where that railway track is going towards. You can add the length of that section. In meters, might be 3,000 meters. Distance between the tracks would be 1 meter. And you just basically go on. So you can add, of course, the sensors to the section. So you have a list of sensors that are available. Here you have a status of the sensor. So whether or not the sensor is online on the platform, so whether or not it's actually sending the data. So you can save it. You can add another one. And when you add, of course, the second one, you also have to provide some information like the distance between the previous one. So it might be 20 meters, for example, and so forth. So, you configure your section. And again, you configure the part that is the tail beams on the chain. You can just create, a new chain. So it's basically what I want to tell you is that, it's extremely easy once you deploy the sensors on your tracks. It is extremely easy to configure the system and to get to see the data in virtually 5 minutes. Again, you just add the sensors from the drop down menu. You set the length of the bar. I'm talking about teal beams here. So you're just adding, as many sensors as you want. Let's say this one 3 meters, and so forth. And you save. And you see this new section right here. As long as you have the data that start coming in, what you basically see is just, let me just go back to the page, the main page. So you start seeing the data. As you can see, well, on this demo platform, we do not have 100 sensors. We only have, on this section specifically, we only have 5 of them. But anyways, you can basically see, the evolution of those parameters that we've been talking about, of the Cant and of the twist. And again, this graph is, as I was saying, is basically the evolution in the space domain of that parameter. So along the tracks at fixed times. So this would be, for example, the event on the 3rd of November at around 6:30 p.m. This is another time. So, with the synchronization, you can have the data at the exact same time. And that's what gives you the possibility just to group the data together and fix the time and see how that parameter changes along the tracks. Yeah, so this is pretty much what we can do. There is a settlement. There is a settlement that you can see. Again, we only have 3 sensors, but that's the idea. The idea behind the tool, just and this is what's interesting, I think, it's just the possibility to see the data in the time domain, but also along the tracks, just to locate the most critical area where it's worth focusing the attention on. I would say that I am done. I'm open to questions at this point. I see that there's a few of them already. Let me see. I will send the recording. It will be on the website, I think, really soon. What is allowed temperature range for the sensor to be installed on the tracks? Will it work when there's a lot of snow and -20 Celsius? Well, the sensors are certified from -40 Celsius. So there should be no problem in that sense. It's really, they have a wide range, a wide temperature range. -40 plus 80, according to the data sheet. How many sensors can be installed in a chain? As many as you want. You can have 3 sensors, you can have 300 sensors. The idea is just to have actually as many sensors as possible. So just because you would be able in one single chain to monitor at the same time the entire length of your railways. So really there's no limit. Would be a problem for Gateway to cover 300 sensors? Well, the thing is, the Gateway has a certain radius, it has a certain range. So the thing is that you would have to install probably multiple gateways along the tracks, but it would definitely not be a sensor. That would definitely not be a problem. You can have multiple gateways because, one gateway probably gets you up to 40, 50, 60 sensors. And so you can just have multiple gateways to cover for bigger numbers. Again, here it says, what is the monitor frequency in the example? How do you synchronize the time of each sensor? Okay, so the monitoring frequency, I think the monitoring frequency is it's 2 minutes. So we provide, the sensor would provide 1 sampling every 2 minutes. The synchronization between the sensors is actually something that revolves around the relationship between the sensors and the gateway. So it's actually the sensors themselves are synchronized between each other, because they belong to a network and the gateway belongs to the same network. So the communication between the gateway and the sensor makes it in a way that, the acquisitions can be synchronized. Okay, let me see. I have more questions on this other page. Okay. Okay, when monitoring summons. Okay, when monitoring settlement along a railway, how far beyond the work zone or zone of influence should you typically extend the monitoring? Well, I mean, if I understand the question, what you're saying is, I mean, how far you have to go, how far away you have to go with respect of the area that is actually sinking. Is that the question? In the meantime, I'll read the next question here. The tilt meter are dual axis. Why is the tilt meter installed on the sleeper associated for Cant? Not used for the longitudinal vertical displacement. Okay. Considering right. Yeah, I mean, the thing is that because basically so the question is, if the tilt meter are dual axis, why do we use the sensors on the beams and the sensors on the ties instead of just using the same sensors that is on the beams to do the Cant as well? Well, the reason is because we want to be extremely accurate with the analysis, and having a sensor that is on the beam. So there is definitely an additional connection, which is the connection between the railway tie and the beam, and then between the beam and the sensor. So in terms of accuracy, we definitely lose something. This is one of the reasons. The other reason is that not always we want to have both of the monitorings. So we can have either, the one or the other. And the regulations say that, let's say the spacing between the sensors when you're monitoring the cant and twist and the spacing when you're monitoring for vertical chains is different. When you're monitoring for cant and twist, you can go up to 20 meters between one sensors and the next. It's not really easy to have 20 meters long beams. So, they are for different purposes. So we would typically just install firmly the sensors on the tie to have the most accurate parameter of torsion. And at the same time, we would install the sensors, on the beams to have another parameter that is associated with it. Okay. What is the fastest reporting rate achievable? At the moment is, if I get the question, the cadence, the fastest is 1 sampling every 2 minutes. Are tilt beams temperature compensated to contain temperature deformation? They're not temperature compensated. Because it's not easy to kind of prevent the temperature deformation, because it's not easy to understand how it will move due to the temperature deformation. So that is not so that doesn't happen. What we're trying to work on is actually predictive algorithms that can compensate that, looking at the data collected previously. So once you have a baseline of data, that at that point we should be able in the future, we're working at that project right now, so we should be able to compensate for that temperature trend, temperature variation. Can your equipment being submerged in a flooding situation? Well, let's say the temperature is the sensor is an IP67, so definitely a little bit of water doesn't affect the sensor. Well, of course, if you install the sensor in an area where then it's covered in water for days and days, that becomes a little bit more complicated. But I would say, in a general sense, a little bit of water shouldn't be a problem for the sensor. Do you deal with a chain? How do you deal with a chain only give you relative movement? Will now require geodetic confirmation or absolute location? Well, yeah, I mean, the thing is that, with the tilt meter, the idea is just to be able with the chains, just to be able to locate the first point, which is a fixed point, the second point, which is another fixed point, and then we can do the deformation, which is pretty accurate in between those 2 points that we take for granted they're not moving. Of course, I mean, at the end of the day, the same problem you have it with a total station when you don't know for sure that the point where the total station is installed is not actually moving, so the same problem is shared on any type of monitoring system in some way. Can you set alert on any parameter, including settlement? That's what we're working on. The next release of this tool, which will happen shortly, will have definitely the alarms on the parameters. Right now, you can set the alarms on the value on the raw data detected by the tilt meter. So you can set an alarm threshold, and you basically receive an email whenever that threshold is surpassed. So you can set your own on the platform. You can set your let's say your email account, and you can get the emails whenever that threshold is surpassed. What we will do in the short future at this point, since that we're releasing this tool at this point, the next project on this tool is we provide the alarms on the measure on the measure provided by the tool, so on Cant, twist, and the vertical displays. That basically answers the question that was below that. So if you can set a flag notification when the Cant, twist, and other parameters reach a certain point, again, yes, that will be in the next update of this tool. When the rail is moving on the track, is there any effect on sensor due to vibration? Okay, well, I mean, the sensor basically this is a static sensor for static monitoring. So we want to detect the static component of that. So just to mention it, it's something that it's not on the tool right now. Something else that we will have would be the possibility basically to have with an accelerometer that is inside the tilt meter, we would be able to kind of discriminate between those events that happen during a vibration and the events that happen when there was no vibration. Does your equipment have to be removed for track maintenance? Well, I would say typically not, but just because, I mean, depends on what track maintenance means. Removing the sensor from the railway is something pretty easy at the end of the day, because you just unscrew. You basically have two screws, or you have epoxy, or there is other options. But just basically a small box that you can just connect and remove pretty easily. So I would say the thing that is important to understand is that the sensor is quite small, and so I would say typically not, unless the maintenance is extremely invasive. Well, I think there's no more questions. So at this point, if anybody has any other question, otherwise, I think this is it for today. Let me see if I have another question. Okay, thanks. Perfect. So thank you so much for taking part in this webinar. It was really nice to see a lot of participation to it. So I'll see you in the next webinar. Thank you.